Hello, my name is Professor Johnson, and I will demonstrate some uniform distribution examples for you. So the uniform distribution is a continuous distribution. That means what we need to find is area under the curve in order to represent probability. So in general, for this example, I will draw my x-axis, and then here I'll have my y-axis, or my outputs, f of x. And if we think in general, the uniform distribution travels from A to B. So here we have x is distributed uniformly from 23 to 68. The 23 would be A, and the 68 would be the B. And then we'll find the probability. The probability goes with area. Uniform is represented as a perfectly horizontal line. So this will be our curve. What we're going to do is find area under a curve, but you see how we made a rectangle here. To find area, we just multiplied base times height. Base times height would give you the area under the curve. So here we need to understand what the height of this distribution is. You would be taught this in class, but it would be 1 over b minus a. And that gives you an area of 1 under this curve, right? If you found the area of the entire curve here, the area would be represented as 1 using this setup. So what I'm going to do is draw a new curve. Okay, so that's in general. I'm going to draw a new curve to this example. So A was 23. B is 68. So then we have a uniform distribution. So I'll draw a uniform horizontal line. And then I need to find the height here. Okay, so my f of x. My curve is represented by 1 over b minus a. Now in this example, b is 68 and a is 23. So I need to know what 68 minus 23 is. So let me get my calculator. And I will do 68 minus 23 is 45. So I can represent the height of this as 1 over 45. Okay, let me zoom out a little bit so you can see where that came from. 1 over 68 minus 23 gave you 1 over 45. Now let me point out a couple points to make with the 1 over 45 as the height. I'm going to leave it as a fraction like this, because if you look at 1 divided by 45, it is not an ideal value, right? So I'm going to keep it as a fraction. Also, make sure you do not go like this in your calculator. Do not do 1 divided by 68 minus 23. This breaks the order of operations, right? And you'll see that it actually gives you a really insane number. Negative 22.985. That's the height. Well, that's questionable. What you really need to do if you want to do this in one go is put parentheses around the denominator, and then the order of operations is preserved. Because now you'll do parentheses first, right? What's in parentheses, you'll do the subtraction first, and then later on you'll do division last. In the wrong way that you see here, 1 divided by 68 was done first, then it's subtracted by 23, which is why you got negative 22 point something. So then you can see that worked out. As a hint, you can hit the math button, go to fraction, and that will always give you the reduced height if you'd like. So we have our height and we have our drawing. So then what I like to do next is think about probability. The probability must be x is greater than 50. So what I'm going to do is mark 50. 50 is somewhere in between. And then I am going to shade greater than 50. Okay. Now what I want to do to find probability, you need to find the area. Okay. So that shaded region right there will be my area that I must find. So what I'm going to do is say, well, area of a rectangle is just base times height. Okay. Well, the height we found, right? We know the height of this curve, right? The height of this curve is 1 over 45. We already found that, right from here, 1 over 45. Okay, so that's a very important piece of our puzzle. Next, we need to know the base. Okay, the base is this, shaded in green. So I need to know what is 68 minus 50. 68 minus 50. So now I can take my calculator. 68 minus 50, well, that's 18. And we're going to multiply 18 by the 1 divided by 45. Now I'm going to put it in parentheses just to make sure nothing bad happens. So we get 0.4. So our area would be 0.4. But this is a nice terminating decimal. If you wanted to, you could leave it as a fraction. So 0.4 or 2/5 would be a valid probability answer in this example. Let's do another example. So let's deal with some decimals. So suppose x is distributed uniformly from 12.4 to 18.6. Find the probability that x is less than 13.5. So what I want to do first is draw a picture. And I know it goes from A to B, so I will mark 12.4 and 18.6. Now we have a uniform distribution, so I'm going to make a rectangle here, and then I need to figure out what my height is. Okay, so my x values go along the x-axis. My output, f of x, will represent my height here. So I need to find 1 over b minus a. Okay, 1 over b minus a. 1 over 18.6 minus 12.4. So you'll have 1 over something. Now, it's much easier to just figure out 18.6 minus 12.4 just on its own. 1 over 6.2. So I will put 1 over 6.2. If you wanted to, you could do 1 divided by, and then put parentheses. Remember those parentheses, otherwise you'll have some issues. Okay, and you'll get a wild decimal. This is why it's nice to leave it as a fraction, so that we don't have to deal with rounding. So I'll go to the math button, pick fraction. Okay, 5 over 31, that is actually equivalent to 1 divided by 6.2. Okay, so you could leave it as 1 over 6.2, or you could leave it as 5 out of 31. Either way, it's a perfectly valid answer. Okay, so 1 out of 6.2 is equivalent to 5 out of 31. You can use either one, okay? They are equivalent. So that height is represented as so. And I'll even show it both ways with both heights. So then, to find probability, we need to find area, okay? We find area under the curve when you have a continuous distribution. And the uniform distribution follows a continuous distribution. So 13.5, I'll mark here. We mark it in a different color. And then I want less than. So less than, I will shade to the left. So then I am finding the area, right, of this little region there. Okay. If it helps, you can even draw a different rectangle off to the side. Right, 12.4 to 13.5 is represented there, right? And then the height of this is 1 over 6.2, right? Or 5 out of 31. Okay, so it's that little rectangle. If you think of plucking it out and redrawing it, you could do that as well. Okay, so what I really need is to know from 13.5 to 12.4, how long is that? Okay, so 13.5, and I will subtract 12.4. That is 1.1. So then you know that base is 1.1. Okay, so we're finding the area. We will do base times height. The base we found is 1.1. The height would be 1 over 6.2. Okay, or you could do 1.1 times 5 out of 31. I will show both ways here so that you can see it would give the same answer. So 1.1 times 1 out of 6.2 is the same as 1.1 multiplied by 5 out of 31. you'll see that it gives you the same value, right? It doesn't matter which one you pick, but this is not a nice terminating decimal. So I don't want to round, I want to get an exact answer. So I will hit math, go to fraction, hit enter, and I get 11 out of 62. Okay, 11 out of 62 would be my nice answer here for the probability that x is less than 13.5. It's what I call an exact answer. Thank you for watching my video.